Hi, this is the introduction to my Universal Design for Instruction video. In this video, I will be teaching a section on geometry. My part of the group is specifically focusing on congruent and similar triangles, starting with translations, rotations, and reflections. In this video, it's going to be a screencast since I am working with students online. So in the video, you will neither see me nor the students, but you will hear our voices as instruction goes on. The way that I am teaching this is we're using a whiteboard program, and then I have a program that allows both myself and the student to have control over that whiteboard. So I can write out equations or show demonstrations, and then they can write back to me to show that they are comprehending the material. Specifically in this video, one of the accommodations that I'll be providing for my student is that they struggle with definitions. If I were to give out a definition and say, this is what a reflection is, they're not going to understand that. I need to show an example. So in this case, I'm going to pull an example from a real-world experience and draw a picture, relate it to a real-world experience that they have seen and viewed, and it's going to help them commit the principle to memory as well as help them with understanding of the principle. So please enjoy this video on math instruction. Last week we talked a little bit about similar shapes and how shapes can be similar or different from each other, and we're going to continue that today by talking about congruent and similar triangles. But first, let's talk about how we can manipulate shapes, all right? So let's pretend that I've got, let's see, where we go? There we go. Let's pretend that I've got this graph here, right? This not very well drawn graph, but it works. And there's the x-axis. So let's pretend that I've got this right triangle, all right? And I want to change it. I want to change its position on the graph, but I don't want to change its shape. So the first thing that we're going to learn about is called, or the first form of transformation is called a rotation. Rotation. And remember, as this is it, so this is a definition, so we need to make sure that you have this in your notes, okay?
Yeah.
Now, what a rotation is going to do is it's going to flip or rotate this image around a central point. So I want you to think of a clock, right?
Okay.
And here's the hands of the clock. Now the clock, as it moves, it goes around clockwise, and it doesn't change, like this length doesn't change. It just moves direction, correct? So we're going to apply a similar movement to this triangle. So let's pretend I'm going to rotate this triangle around this point, and I'm going to rotate it counterclockwise. I'm going to go ahead and give you mouse control. Hold on. Okay. I would like you to show me what might happen to the triangle as it starts moving around this central point. All right? So go ahead and show me what this triangle might look like. So just imagine, so we have this shape, and like a clock, it's just rotating as a whole block. All right? And show me what it might look like around in this when it gets to around this point over here. Go ahead and mark it. Like when it's over here.
Yeah. So I think it would probably look of what I think is from logic. It would probably look thinking. Probably something like this.
Okay.
Of
Very good. Yeah. Your logic, your intuition was correct.
Yay!
So, I mean, okay, I have another program where we could actually open it up and play around with these, but we'll do that if we have time at the end, because we don't have a whole lot of time today. But yeah, so if we look here, if this were to flip up and around, let me choose a different color. Let's get green. I like green. So let's pick something that we can follow, and let's follow the right angle. So as the right angle moves up, it's going to be up here. And you have shown that right there. Very good. And still we have that dot. Now, here's the only thing, is that it would have to stay around this point. If we're rotating around this point, here, I've actually got a way to show this. We are going to take your image here, and we're actually going to cut it. So instead of being over here, because that's actually a different type of formation when it actually moves in a different spot, its bottom part would still be tied down to that angle. Does that make sense?
Yeah.
So, yeah,
like that.
Just like a clock. Okay. All right. So do you have that in your notes?
Yeah, I do.
Okay. So for the next thing, this is going to be called reflections. And what I want you to imagine is you're at a nice sunny lake. Those are kind of big waves for a lake, but whatever. You're camping there with your family. And you notice, as you're staring at this lake on this nice, beautiful, sunny day.
I look a little bit evil.
Here, we'll give you a... There.
Like an evil top hat or something.
There's your evil top hat. So you notice as you're looking at this lake that there's some mountains in the distance. Some nice, beautiful, snow-capped mountains.
Yeah. They look so beautiful.
Oh, thank you, Cameron. Now you notice, so this is water. I should use blue. This is, no, sorry. Make it blue, please. This is the blue water, right?
Yeah.
And you notice, I'll use a gray color for the reflection, that the reflection of the mountains, they kind of look like they're upside down. Right?
Yeah.
And this is how we deal with reflections in geometry. All right?
Okay.
We have a single line. And this line, in this case, it was the lake surface. This line is the reflective line. Yeah?
Oh, I think I lost you for a second.
Oh, sorry, the connection might have been a little bad. Can you hear me okay?
I can hear you.
Awesome. All right, so this line is the reflection line, and we can flip objects over the line, right? So reflection just means we flip it. Okay?
Okay.
Awesome. Now, the next thing is called translation. And a translation is when we just pick up the object, the movers come knocking on the door, and they're like, hey, you can't be here. They take the object and move it to a new location. They don't change the object in size and shape. They just pick it up and put it down. Does that make sense?
So like copy and pasting it.
Yeah, exactly. So you have yeah, pretty much exactly. So it's basically, here, I'll go ahead and copy and paste this one. All right.
I'm copying and pasting it in my notes.
Awesome. So I were to take it, and it's like, oh, we're gonna move you over here. So I don't change the way it looks. I just move it.
Okay.
All right, now, here's the thing that we've been leading up to. I told you earlier today that we have, there's a difference between congruence, let's see if I can spell this correctly. So I'm a math teacher, not an English teacher. Congruence and similar.
Yeah. What does congruent mean?
Congruence means that the shape, so in this case, a triangle, because we're learning about triangles, remember? Next week tomorrow we're gonna talk about the Pythagorean theorem. The triangle, it's going to have the same angles and the same sides. Same angles, same sides. All right?
Okay.
So, for example, so we're talking about congruence right now. I have a triangle that's 30, 60, 90. All right, so here's my 90 degrees. Here's my 60 degrees. And here is my 30 degrees.
Okay.
And we're going to pick some arbitrary lengths. Let's pretend that this is 12, and this is 3, and this is 5, and these are in inches. Now, I don't know if these numbers actually work out. We're just throwing arbitrary numbers out there. We can figure out if this is correct tomorrow when we talk about Pythagorean theorem. All right? For a triangle to be congruent, it would have to look like this. Whoa! Do you see that?
Yeah, I do.
It has to be the same. Now, here's the trick though, is that, let's see, again, I can't, no, that's not what I wanted to do. Oh, I know how we can do this. Watch this. All right. This is also the same. So technically what I did there is I did a rotation on it. I flipped it. But it still has the same sides and the same angles, correct?
You know?
Yeah? Did I cut out again?
Yeah, just your voice, but you're good.
Okay. So what I said is that, so here I've taken this triangle and I performed a transformation on it. Right?
Yeah.
Have I changed the angles or the side lengths at all?
No.
No. That's the thing with congruence. I can do translations, I can do reflections, I can do rotations. As long as I don't make it bigger or smaller, it's congruent.
Okay.
All right?
All right.
So here are some rules with congruence. If, and so these need to go in your notes. We don't have time to talk about these today, but we're going to pick up where we left off, and we'll finish talking about these tomorrow. Oh, that's why. Technical difficulties. If the sides are the same, if all the sides, side, because there's 3 sides to a triangle, if all the sides are the same, it's congruent. All right?
Okay.
If I have a side and an angle and a side that's the same, it's congruent. The other combinations I can do is angle, side angle, or I can do angle, angle, side. And again, I'm going to talk about these in more detail tomorrow when we continue our class. But really quickly before we end, because we are just about out of time, the bell's gonna ring and you're gonna have to go to lunch, oh darn it. Math is gonna be over, the torture will be done.
Yay!
The last thing I'm gonna talk about is similar triangles. Now with similar triangles, the only things that need to be equal are the angles.
Okay.
So here is where we get into, here's my 30-60 triangle. It's the same as this one, it's just a lot smaller, right? Versus, and then I perform a transformation on it, but I enlarge it. It's kind of going to go off the page here because it's just too huge. It's just too cool. All right? But it's, again, 60, and you can't see that over there, but that angle down there is 30, and this is 90. These angles are similar. So maybe instead of having 12, 3, and 5 inches, maybe it's got like 115 inches for this side. You know what I mean? It's a big triangle.
Yeah.
But as long as... he had too many brownies. So as long as the angles are similar, or as the angles are the same, the triangle is similar. All right, any questions?
No.
Awesome. Will you really quickly, in your own words and using your own examples, tell me the difference between a congruent and a similar triangle?
Well, a congruent means same angles, same sides. So it's kind of like a triangle, or if you had like a triangle that has it's three inches on the left, the right, and the bottom.
Mm-hmm.
And similar is like they look the same, but they're not really the same that much. So like they look the same, but they're different measurements. Say if one was smaller and one was enlarged.
Okay. What about the angles? Do the angles have to be the same for similar triangles?
Yes, they do.
Awesome. Yeah. Looks like you're getting it. All right. I will give you your homework assignment in a little bit. But for now, thank you for participating in this math lesson. And we'll see you later, Cameron.